Hello and welcome to the Chapter 2 podcast on Section 6. So today we're going to be talking about molecules and molecular compounds. A molecule is basically a non-metallic atom, more than two of them, that are tightly bonded together through a chemical bond, which we'll talk about very soon. There are diatomic molecules. These are molecules made up of two of the same kind of atom. Remember, there are 7 diatomic elements, and we talked a little bit about this after the diagnostic exam. So the way to remember the 7 diatomic elements is using the little mnemonic Hofbrinkel. So hydrogen, which is illustrated here in this figure on the bottom, oxygen, fluorine, chlorine, bromine, iodine, nitrogen, and chlorine. So these are the 7 diatomic elements. So these are always found paired with themselves in their purest form. Chemical formulas represents a symbolic form of a molecule. Examples of some of these are listed here in terms of their name. Sometimes it's a common name, sometimes it's a name based upon a certain naming rules, which we'll talk about in this chapter. And then this is the H2O, the CO2, for instance, represent the formulas. And then these we'll talk about in a moment. These are actually space-filling structural formulas, which are a little bit different. Molecular compounds are molecules containing more than one type of atom. So while we have diatomic molecules, over here we have molecular. These will all be considered molecular compounds because they're made up of at least two different kinds of elements. We also have molecular, empirical, and empirical formulas. Molecular formulas are basically, they indicate the actual atoms that are connected together for a particular compound. So for instance, peroxide, its formula is H2O2. Okay, and this basically means that there's specifically two oxygens and 2 hydrogens connected together in one clump. For ethylene, it'd be C2H4. We can use molecular formulas to determine empirical formulas, but we cannot go the other way. In other words, I cannot use an empirical formula to determine a molecular formula. Unless I give you extra information, which we would do in a future chapter. Empirical formulas are basically the lowest whole number ratio of a chemical formula. So while the molecular formula peroxide is H2O2, notice the empirical formula for peroxide is reduced. Okay, and the same thing for ethylene. Now, empirical formulas, historically were the first formulas for some of these things that were actually reported, because a guy like John Dalton had no idea what the difference was between a molecular and an empirical formula. Okay, so lab analysis can lead to empirical formula, but if you actually weigh out the purified molecule, you can sometimes measure the specific difference between an empirical and molecular. In terms of representing molecules, we can represent them in several different ways. So a molecular formula just tells you composition. It really doesn't give you information in terms of who's connected to who. A structural formula are the ones we'll probably use most often in class. This is like a simple 2-dimensional formula that shows elements connected to the other elements. A perspective drawing, where you see these dotted lines and these triangles, are trying to give like 3-dimensional depth to the structural formula. Sometimes you'll see ball and stick models, and we'll actually create some of our own ball and stick models later in the course, where we actually, this represents an accurate 3-dimensional representation of the bond angles. And you might have actually done these already in your biology class if you built some simple organic molecules. Space-filling model, these depict what the compound will really look like if we took into account the spatial volumes of these elements as they connected to form compounds. So keep these in mind, as representing these molecules in these different forms can tell us different things about our molecules themselves. That's it. Oops, wrong one.